All right, so question 48 says, are these triangles congruent? If so, explain how you know with a flowchart you may need to label the vertices, and then indicate a sequence of transformation that maps one triangle onto the other. If they're not congruent, explain why not. These triangles are not drawn to scale, which is kind of evident immediately because I have this 90-degree angle that doesn't look like a 90-degree angle. So one of the things that I'm curious about is what's the measure of the missing angles, right? So you know what? I'm going to go ahead and well, let's find those. So if I look at this triangle first, and I take the 180 degrees, right? The triangle angle sum theorem. The three angles in a triangle always add up to 180. Um, and if I subtract the 90, it gives me 90, and I subtract the 60, that clearly lands me at 30 degrees. So I know that this angle has to be 30 degrees, right? And if I look at the other triangle and do the same thing, I can see I've got a 30, 60. This one has to be 90. It has to be 90 degrees. Um, because 90 plus 60 is 150, plus 30 is 180, or 90 plus 90 is 180. So because of this, I can see just looking at these, I've got this angle that matches this angle. I've got this side that's 8 that matches this side. And I've got this angle that's 30 that matches this. So I can see our triangle congruence condition, angle, side, angle, is met. So these triangles are congruent to each other. So now I just need to organize this as an argument in a flowchart proof. So I think my strategy is, first of all, um, I should label these. I need to label this diagram, right? So I'll call this angle A, I'll call this angle B, and I'll call this C. And then over here, I'm going to start with the 60. I'll go D, and then I'll call this E, and I'll call this angle F. So now I can talk about these parts. So the first thing I want to do is establish what the measurement of angle B and the measurement of angle F are, right? And in order to do that, I need to know the other two the measurement of the other two angles. So I think my structure is going to look something like this. This oval is going to be used to establish what the measurement of angle B is. This oval is going to be used to establish what the measure of angle F is. And those two statements I'm going to make, they're going to be the triangle angle sum theorem, require that I know the other two angles. So I'm going to list what the other two angles were. So for this first oval, and I think I need to make my pen a little bit finer here. There we go. So this first oval, I'm going to say the measure of angle A is 60. The measure of angle A is 60 degrees. And the measure of angle, what was the other one, C? Yeah, the measure of angle C is 90 degrees. And that's given, right? That I read that from the diagram. Now that is going to go into this oval. And because I've got this triangle with a 60 and a 90, right, it has to be that the measure of angle B has to be 30 degrees. And the reason that's true is I'll write this here, it's the triangle angle sum theorem, which just says, hey, the three angles in a triangle add up to 180. So it has to be that. It's just a subtraction problem. Same thing for the other triangle. I've got the measure of angle E is 30 degrees, and the measure of angle D is 60 degrees. That was given. And because of that, I know the measurement of angle F has to be 90 degrees. Okay. So now I can talk about those other angles. And this is, again, triangle angle sum theorem. Now what I want to do is I want to go ahead and flow into this angle side angle. So one of the things I can say is clearly there's a side that's congruent, right? CB. It's interesting. I should say that CB equals 8 units and equals 8 units. And since those two segments have the same length, right, it has to follow that because they have the same length, they have to be congruent to each other. So now I can say segment CB is congruent to segment EF. So you can see that for line segments are congruent if they have the same length. Well, these two line segments have the same length, so they're congruent to each other. So these are congruent because they meet the definition. I need to turn off shape recognition. They meet the definition of congruent segments, right? Two segments are congruent if and only if they have the same length. Okay. So we've got our segment, right? We've got our side and the angle, side angle, but we're still missing the two pairs of angles. So one thing that I can say now is I can say that angle E is 30 degrees. Okay, so let me put this over here. I'm going to say, oh, now I want the shape recognized. There we go. I want to say the measure of angle E is 30 degrees. That was given on the diagram. And yeah, it was. Oh, but I don't really want E over here with this one, do I? No, I do. So what I can say now is because E and B are both 30 degrees, I can say that angle E is congruent to angle B. So two angles are congruent to each other if and only if they have the same measurement. And again, this is the definition of congruent angles. Right? So definition congruent segments, definition congruent angles. Now this requires that E and B both be the same measurement, and they are, right? They're both 30 degrees. So now we've got a pair of congruent angles. We've got our pair of congruent sides. We just need one more pair of congruent angles, and then we can put the whole thing together. And what we need is we need to point out that the measurement of angle C is 90 degrees. So I'm going to put this right here. The measure of angle C is 90 degrees. That was given on the diagram. And because F and C are both 90 degrees, we can now conclude that angle F is congruent to angle C. And again, this is just the definition. It's the definition of congruent angles. So do they meet the definition of congruent angles? Do F and C? Yeah, they're both 90 degrees, right? C was 90 degrees because that was given. F is 90 degrees because of the triangle angle sum theorem. Okay, so if we look at all the pieces now, you can see, back to our original diagram, you can see I marked C and F congruent with a red dot, and I've got that. I marked B and E congruent, I marked them with the blue dot, and I've established that. And I also have established that CB and EF were congruent, I marked that with the green dot. So all the things I intended to do are done, so now I need just one more oval to finish this. And I could say, for example, that triangle BCA, and I will list it that way, triangle BCA is congruent to. All right, so everyone should pause the video at this moment and say to yourself, what has to go with BCA? BCA is congruent to. All right, I'm going to assume you've unpaused it now. So B goes with E, so I'm going to say EFD. EFD. And why are these two triangles congruent? Because they meet the angle, side, angle, triangle congruence condition. So you can see that I've got a pair of angles here, another pair of angles here, and I've got the side that connects those angles here. So everything is structured to support this assertion that I'm making. And I think it's important to point out that obviously when we're coming up with arguments like for anything, right? We don't typically write them out and think about them like this, but sometimes it's a nice idea to kind of be aware of our thinking is on a particular topic and think about the evidence we have for certain claims that we make. So what's nice about a flowchart proof is it kind of throws all of our evidence out, and we can just see how things are connected to each other. And I encourage you to think about, if you have a opinion about a particular topic, or you've been thinking, or someone's made an assertion that you kind of disagree with, you might kind of lay out the evidence and see, well, the things that they're saying, are they supported by the evidence? And then you get into the question, well, what's evidence? What's given? Or what are the things that we agree to be true? And then from those, can we argue to say an ultimate conclusion here? You know what? Based on what we're saying, it has to be the case that these things are true. So it's just a tool to organize your thinking, a flowchart proof. There's certainly other forms of proof. As someone who has a degree in mathematics, there's other forms of proof that you'll encounter, um, and sometimes there's legal assertions. I don't know that things in law are necessarily rise to the level of a proof, but definitely we make arguments, and arguments that are well supported tend to be more believable. So there you go. Question 48, a flowchart proof.